This is actually 4 rooms. Ooh. And then we split it. We split it up in between after the keynote and so forth. So that means changing all of the wiring, consolidating all of the audio. And we got an amazing team that they can pull us off at all, but it is not a trivial thing to do. So just if you're aware, that half-hour break while you were having coffee, there were many gnomes running around here, moving walls and reassembling things and so forth. So sometimes a battle with audio, sometimes a battle with computers. Anybody watch Mr. Hanselman's keynote earlier? Have you ever seen a more elegantly managed blue screen in your life? It was impressive. And then the man hung Notepad. I don't think I've ever seen that before. That's special. Took down Notepad all by himself. So, but yeah, I've known him for a very long time. He's done a lot of talks for many years, and he can handle it. I knew, I was sitting in the corner over there. When he went down, it's like, he could do this talk without any machine at all. He'd be fine. So it's sometimes hardware cooperates, sometimes it doesn't. It's a bit of a challenge. Couple of housekeeping notes before we actually get rolling here on this keynote. Xbox One S pickup is tonight over in the expo hall. How's lunch been? Is the food good? Thanks. I'm a firm believer in no box lunches. I like hot food and I like choice. So we try very hard to make sure that you have a good set of options there. And please let me know if it's working for you. If it's not, I got a request for dessert at lunch. It's like, there's an interesting idea. So, okay, dessert at lunch. I will take that under advisement. I appreciate that. We try and make the show exactly the show you want it to be. That's why we have all of those forms and ways for you to give us feedback. We take all that in and work on it for the next show, try and make the best show we can make. We've been doing this now for 4 years, and we want to do it for many, many more. So beside the Xbox One S pickup later on today, there's also the draw for the cruise at 6:15 sharp, and that'll also be in the hall. You'll hear us make a bunch of noise when we do that, and that's just part of encouraging you to fill in your evaluation forms every way that we can possibly do that. You guys got slides? Excellent. Networking is your friend. A couple things about me. I make podcasts. One of them is .NET Rocks. Any .NET Rocks listeners? Yay. So we make that show 3 times a week. We're at about 1,370 episodes. My friend Carl Franklin, who was the guy playing the music you heard coming in, started it back in 2002, which is about 3 years before the word podcast actually existed. I came on his show as a guest on episode 69, and he asked me to be co-host on show 100, so I'm the new guy. I started in 2005. Also lit up an IT podcast in 2007 called Run As Radio, focused specifically on the IT audience. Do that once a week every Wednesday, and I just published the 500th episode of Run As Radio this week. So I think I've just about got it figured out. And then pretty much everybody you're gonna see around this show has been on one or the other podcasts at some time or another. So it's always a challenge to keep coming up with shows. So if you're doing the math, I do 208 podcasts a year. And it's a constant machine of just cranking out as many shows as we can. And once a month, I do a show called A Geek Out, which is whatever geeky topic the audience wants. Just published one on Elon Musk's interplanetary spacecraft. You guys all saw that. Apparently Elon's going to ship 1 million people to Mars. We don't know what million, but he will ship 1 million people to Mars. So I was trying to figure out, is that actually feasible? And to build spacecraft quite that large. All right, I think we should bring up our guests here. We've got Jules, good timing, Jules Kremer and Brad Green, both of Google. Please come on up. Big hand for our folks from Google and some great Angular content. Great to see you.
Thanks. You staying there?
I'll stay here.
I don't know. Do we know how to put the slides on screen?
Number 2.
Number 2. Awesome. Do we have slides? We have slides. Yes. Good afternoon, everyone. I'm Jules, and I manage developer relations on the Angular team at Google. So thanks for joining us this afternoon. Back in 2009, when client-side development was still fairly new, we created Angular 1 with the ambition of making it easier for developers to build web applications with a framework that could make some of the hard parts easy, things like two-way data binding and dependency injection. Since then, we've seen tremendous growth with Angular. with millions of developers and thousands of apps built with the framework. And our team has gained years of experience in knowing what it takes to build and support a front-end framework. When it came time to build Angular 2, we wanted to take all of that experience and really focus on building a core foundation that could support a thriving ecosystem and the needs of developers today that are building SPA applications, web applications, and mobile applications. Our Angular 1 team is still at work. They're focused on bringing Angular 2 concepts to Angular 1 where possible. So in Angular 1.5, we released the component architecture that I'm going to talk to you about today. And this gives Angular 1 developers a nice bridge to get to Angular 2. We will continue to invest and support on Angular 1 until such time as the majority of our developers are using Angular 2. So for today, let's focus on Angular 2, what we've built, and why we think it's a great platform for you to build your apps on. At the heart of Angular, nope, go back. I think I have to be closer. At the heart of Angular is this component architecture that I mentioned. And you can think of this component architecture as giving you a way to structure your applications with a natural separation of concerns, so that you end up with a sort of set of building blocks that you can assemble like Legos to build your application. So let's take a look at what that means. All applications, whether they're websites or mobile applications, have the same common goal, and that is to serve data to the user and allow the user to interact with that data. So if we look at this web application, which is a superhero storefront, because everyone needs an awesome superhero outfit, and we take a look at it in this component architecture frame mindset, what we'll see is that we have an app component. And the app component really encompasses our entire application. And that component has child components. And if we look at those, we'll see we have a navigation component. We have a sale component that's highlighting our current Cape sale. We have a product component that's used multiple times on this page. And our product component has a child component itself, and that's the Angular Material button component that I took out of the Angular Material library. So looking at our site, you can see everything is a component, and we piece these together to make our application. So what's this component thing? A component is really a combination of your template and the code that sits in the component's class, with a set of metadata properties that describe that component to the rest of your application, with things like, hey, what's my component's name? So let's take a deeper dive. I'm going to show you some code and explain how all these pieces sort of work together to create those building blocks. Starting with templates. Angular 2 templates are just standard HTML. And this is great because you don't have to learn anything new. And it's even greater if you work in a really big team where you might have a workflow between UX designers and QA testers, because they don't have to be Angular experts, but they can still understand and use and work with all of your templates. One of the most powerful aspects of Angular is our property and event binding. One of the most magical moments in Angular 1 was the first time you discovered two-way data binding. Has anyone had that experience? No one used Angular 1? But there was a lot of syntax in Angular 1 that you had to remember. And so in Angular 2, we really wanted to focus on simplifying Angular 2 so it was easier. So we've dropped 40 things you have to remember so that to get property and event binding, you have two things to remember. One, if you want to do property binding, you simply use square brackets. If you want to do event binding, you use parentheses. And if you want that magical two-way data experience again, you just use both of those notations together. In our code example, though, you might notice an interesting piece of markup, and that's that ng4 statement. This ng4 statement is a directive. And Angular has two types of directives. Structural directives that allow you to modify your view and create elements on the fly. So in our code example, if we want to create a list item for every hero in our hero's object, we can simply use the ng4 directive. And that gives you exactly what it sounds like, a for loop in your HTML template. Say we want to show an element only if a condition is true. We can use the ngIf statement. Attribute directives allow you to modify the behavior of existing elements. So in our example here, if we want to default the inputs text box to our hero's name, we can use the hero name property in combination with the ngModel directive. And you'll notice that example has that two-way data binding because it's using both the brackets and the parentheses in its notation. But what happens when a user wants to interact with your page? What about if there's a button click and you want to take care of what happens behind the click? Well, you do that in the components class. And you can think of this class as the same thing as the code behind an ASP.NET web form or the code behind a SharePoint web part. And it's just code. And you can see in our example here that we have our local template variables initialized, and we have a method that allows you to change the selected hero. But the interesting part of this is also in that init function. So you can tell we're actually populating our heroes object from a service. And this makes sense, right? Because if you're building a bunch of building blocks, there may be more than one component that needs access to that heroes list. And so the question becomes, how does Angular handle service composition? In Angular, services are just a class. You write some code, you go get some data, you manipulate that data, you return the data. This is not unlike every other service you've probably ever written for every app you've designed. The magic of Angular comes with our dependency injection framework. You might notice at the top of this class is that @injectable attribute. Angular 1 pioneered dependency injection for web development, and with Angular 2, again, we want to simplify it and make it easier. So Angular 2's dependency injector is responsible for managing the instances of each of your services. And then you tell each component which services are available to it by just adding them to the component's constructor. So in our example here, our list component has access to the hero service. But if it also needed access to the power service, you simply add it to the component's constructor. So you can see with the components and with our service layer how it's really easy to develop complex apps that have reusable components and shared services. But there's one more step in the component architecture, and that's how do you get your users around your app so they can see all these great views you've just developed. And we do that with Angular's component router. So the component router allows you to have a path to each component. In our example here, we have a crisis center path, and we have a heroes path. Then in your template, you marry that using a router link directive so that you're creating links to each of the paths that you declared. And finally, you drop a router outlet directive in the page where you want the view to be put. So you can think of the router outlet as a placeholder for the paths component view, so that your user experience looks something like this. I click on heroes, and I get a hero list. And when I click on Crisis Center, I'm going to see a list of the current crises available in the world. I was having a really hard time with that word earlier. This is a really simplistic view of the router. It's capable of so much more. It can do things like parameterization of routes, auxiliary and child routes, and also just a very fast overview of the basic building blocks of Angular as a whole. But there's things we knew we could do to make Angular even better, and so we have even more Angular. We have Angular Material, which gives you a toolbox of material-based design UI components so that you can go from zero app to beautiful app really fast. We have I18N for your internationalization needs. And Kara Erickson, whom you may have seen this morning doing an incredible overview of Angular Material in one of the other rooms, has built an incredible forms module that allows you to do user input forms with validation super, super fast. We have animations so that your apps look and respond with style and users like to use them. And we have ng Upgrade, which allows you to mix and match Angular 1 and Angular 2 components in the same application, so that if you're one of the millions of Angular 1 developers, you can migrate at your own pace. So I've talked about the building blocks of Angular. What about all the places that you need your apps to run? Angular was born for the web, but we want to make sure it addresses today's needs and can run everywhere. So we build great websites, but we also support progressive web apps, which allow you to create hybrid apps that you can progressively enhance for mobile devices all the way through to offline scenarios. For some apps, especially consumer apps, a presence on an app store is super, super critical. And so for those types of apps, we've partnered with Ionic and Onsen UI that allow you to use all the goodness of web technologies, but still package that app for the App Store presence. If you prefer native, Telerik, who is here today, has NativeScript, which works with Angular 2 by swapping out our renderer for one that can render to native. And finally, for the desktop, because we all still go to the office or work at home with powerful desktop machines, we have a project from GitHub called Electron. And Electron allows you to use Angular 2, building your app, and still taking advantage of all the machine resources. If you're using VS Code, for example, that's an Electron app. But Angular needs to run even where no DOM exists. And so we've invested in server-side rendering so that if there's no DOM, the server can render our components view. And this currently works in Node and ASP.NET today. And we're looking for some other opportunities. We're talking with Java and PHP and Python to see what we can do there. So I've talked about the building blocks, and I've talked about where your apps will run. What about what you as the developer will use to develop these apps? With Angular 2, you can use ES5, you can use ES6, or you can use TypeScript. We're huge fans of TypeScript on the Angular team, and we built Angular 2 in TypeScript because of all the value we thought TypeScript could bring. It made us capable of building our framework faster. We could find bugs faster. The readability of our code greatly improved, and this was super important because we have multiple engineers working on multiple parts of the framework, and they could get started much more easily. And we found that we could build much better tooling, like the Angular CLI. With our command line interface, you can type ng new, and we'll create all the scaffolding and all the boilerplate for you, so that when these commands finish running, you can simply type ng serve, move over to your local browser, and your app will magically be there, functional, so you're left writing application logic, not boilerplate. Staying true to Angular 1's testability value, we have Protractor, which provides end-to-end testing for Angular 2 apps. And our partners at Wrangle.io have built a tool called Angular Augury, which gives you real-time insights into the performance characteristics and things like routing in your app, so you can debug and see what's happening in your app much faster. And our language services team has worked really, really hard to ensure that your favorite IDE, whether that's Visual Studio or VS Code or WebStorm or Atom, can understand Angular syntax and give you really great error messaging and refactoring tips as you go. So hopefully I've shown you just how easy these building blocks are and where you can run everywhere. But to show you, hopefully I told you how easy it is, and to show you, I'd like to invite John Papa, who's one of our Angular developer experts, to stage to give you 0 to 60 in 4 minutes, 6 minutes, 5 minutes. John.
Good afternoon, everyone. Now, you all saw my password, 1234. Can we switch over to the other laptop, please? Laptop number 3, please, for video. Cool. All right. So what Jules just explained to you is how we build an Angular 2 application and what all the great things are inside of Angular 2. But I wanted to show you how you can actually build an application from scratch. If you go out to the website for Angular, there is a quick start that you can build. And there's a repo a link that you can go to, and you can clone it, and it gives you a great starting point so you can play around. That's at angular/quickstart at GitHub. So that's what I did in advance. And then I pulled the application down, and it should be running here. You should go look at it in the browser. And voila, there's a very simple Angular app. It's like Hello World from scratch.
I think we need to switch the video.
Wrong laptop.
They switched back. And that's it. We're all done. Awesome. So now here's the Hello World application. Great. So in this app, we've got a Hello World, but we want to do a little bit more. This comes from a sample up on the website that's called the Tour of Heroes. So what I want to do is just go through the application and let's add some things to it. First of all, in the app, we have a module. The module is like the container for what is in my app. It's like a manifest. We're using something to display things on the browser. And we have a single component right now which is holding that Hello World up there called app component. And here's our app component right there. It just says my first Angular app. Well, let's just change that over first. Let's say we had a title in here, and we'll make the title be Tour of Heroes. And if we want to display that, we can use the interpolation that Jules was talking about, like this, and it should refresh over here, and we've got Tour of Heroes. So simply, we can see the application re-renders very quickly. Well, this is a list of heroes, so we should create a new component and show a list of heroes, because our heroes need work, and this application helps them find jobs, because heroes are people too. So let's go over here, and we'll create a heroes component.ts. And inside here, I'm going to use a snippet. Now, these snippets are great. You can get them on the Visual Studio Code Marketplace. And if you just slide down, you can do ng2 component. And look how fast I typed. And then you can type in, OK, the selector for this is going to be called My Heroes. This is the name of the HTML element that I'm going to be using in the page to display my heroes. So I'll name it heroes.component.html for where to find the template. And then the name of the symbol is going to be heroes component. Perfect. Well, I just told it there's going to be an HTML page, so let's go do that too. Heroescomponent.html. Then over here, we can add some HTML. We need a list, so we'll create a UL. And inside of Visual Studio Code, we can do things like emit which allows us to write quick HTML. So I know that this guy should have a class called heroes. So I'm going to say ul.heroes, and it's got an li inside of it, which has a span, which has a class called badge. When I hit tab, it just expands all my HTML. Nice feature of Visual Studio Code that comes out of the box. And I know that once I have this list, I want to take this li and list out a list of heroes. So let's kind of play this out. Inside of Angular, we've got this thing called an ng4. ng4 is going to let us loop through a list. So let's say we had something called heroes. We're going to loop through that. We're going to need a local variable for the iterator. And we're going to say, OK, let hero of heroes. So we're going to get a hero instance for each hero in the array. And then inside of there, let's say the hero's got an ID. Oops, need two of these guys. And it really doesn't want to type the second one. There we go. And then we type in hero name. Now, we don't have an object that does this yet, but let's go create that inside of our code. So here's our heroes component. We're going to go up here. We're going to create a heroes right there. And we're going to set it equal to an empty array right from scratch. So we'll do that there. And then we need a heroes object. So let's create a new file over here. We'll call it hero.service.ts. And inside of this, this is just going to be a class. So we're going to say export a class called hero. And then we're going to give it a constructor. And inside of that constructor, we're going to say, all right, it's got a public ID, which is a number, and a public name, which is a string. It's just a constructor function. That's all. So we want to use that hero inside of here. Now we're going to take advantage of ES6 modules. We're going to say import. We'll go to hero.service, and we'll import the hero class. So now we can say, OK, this heroes is of type hero array. And now we have types in there using TypeScript. Cool. Well, inside of our ng init, we're going to initialize our component. You might be wondering, well, what's ng init? Inside of Angular, we have a couple ways we can initialize things. One, inside of a class, you can use a constructor, and the second one is ng on init. The constructor happens as soon as the class is instantiated, just like all classes. The ng on init is a lifecycle hook that starts like on load or on initialization of this particular component. This is a great place to do initialization logic. So here we can say this heroes equals, and we can create an array. We could say create a new hero, and we'll give it an ID of 1, and the first name will be Brad. He's my hero. And then we'll make ID of 2 and 3, and we'll make Jules up here. And Richard's done a great job, so we'll put him up here as well. So we've got 3 different heroes inside of our component, and now I want to display those on the screen. So let's take a look at what we've got. We've got a heroes list up in our component. We have a heroes in our array that we're going to loop through and iterate through, but it's not showing up yet on the screen. It's because we haven't yet told the application that this element needs to exist. So if we go back to our component, remember I created this myHeroes selector. The myHeroes selector is the name of the HTML element that will represent all the logic that I just wrote. So now I go back to my app component, and right below the H1, what I can do is stick in a myHeroes element, like that. A couple of things to take note of here. First, notice that I can do multiple lines on here. That's because I'm not using a quote. If I use a quote right there, notice I get all sorts of crazy errors. If I use a backtick, I can use a multiple lines statement with our strings. Those are template strings. They come from the C# world, were brought into TypeScript and into ES6 and beyond. This allows me to write simple templates in line. So now this should tell Angular, hey, when you see my heroes, go ahead and render this on the screen. Not quite ready yet, because in HTML, is there a thing called my heroes that the browser knows what is? No. That's something I wrote. So we have to go back to Angular. Remember that manifest that I mentioned? App module. App module is where you tell Angular about the special things you created. You say, Angular, and it says, yeah, John? And I say, hey, I just created this heroes component. And when you see that in HTML, this is the selector that you'll see. Please render it with this TypeScript and this HTML. And it says, why, certainly. So first, we have to import in the file. This is like a using statement in the C# world. We say, OK, this was in heroes component, and I should be able to type that in with IntelliSense. And I have to add it to my declarations. I've now declared that this heroes component exists. So it's saying, OK, you now know about heroes component. This is where it is. Here's the code for heroes component. The template is being linked to right there, and I happen to also have some styles. So style URLs, we'll go ahead and type that in here, heroes component.css. I don't want to make you watch me type some CSS. So now we have a very simple list of our heroes. Not too bad, right? Pretty quick. But who likes hard coding? I see one guy in the back raising his hand. I'm like you. Hard coding's not so bad, right? My boss at work calls it explicitly configured. Makes it sound better. Not really. So instead of explicitly configuring my list of heroes here, maybe instead I should call a service, because maybe I want to show my heroes in multiple places. All right, let's take it a step further. Over on our hero service, let's create a class that can give me a list of heroes. Again, I'll lean on my snippets. I can say ng2, go down to service, types it out for me, and my hero service can be called hero service. And it's very simple. I'm going to say, okay, we're using this thing called injectable to tell it we can do dependency injection with it. And then we're saying this hero service has nothing in it, but let's give it a list of heroes like this. And by default, we'll return nothing yet. But what we should do is say, okay, this guy should return something. Let's go back over here. We'll copy our array, come back into our code. We'll now say return an array of heroes. And it knows what this hero is here because it happens to be in the same file. And it's returning a list of hero array. Back in this world, we can now get rid of this code right there. And instead, we have to make the heroes call that other function. So let's kind of do this backwards. What we want to do is say this has some local variable called hero service, get heroes, to go get them. But I don't have a reference to the hero service yet. So what I need to do is go get that reference. I'm already up here in imports, and I should be able to pull that in this way. And then I need to do constructor injection. We're using dependency injection and saying Angular, when you see something called hero service, go ahead and inject it into this class. There's two parts to dependency injection, like in most DI systems. The first one is you ask for the thing you want to be injected. I want a hero service. Well, for Angular to be able to say I have it, somebody has to have told Angular about it. So I have the second step. I have to provide this service to Angular. And where's the place where we tell everything that Angular needs to know? Up in the module. So up here in the module, I say, all right, import this guy here from a hero service, and he happens to be called hero service. And with services, we say, go add a provider. So what this does, it tells Angular there's an injector at the root. We tell Angular, add this hero service to your injector. It knows about it. Now, when the component says, I want to know where is that service so I can use it, it can go ask the injector. The injector says, I have one. I'll give it to you. And then you can use it right in line right here. So if we go back to our application, we still have code running. I can refresh to show that out. But now we can see how quickly we can get things running with patterns that we've used for many, many years. We've got components. They're just things that were showing up on the screen. We've got templates or views. There's our MVC-like model. We got data, the model. We got views, the templates. We've got components instead of controllers. And we've got services, so we can do shared data, caching data, stateless retrieval of information over HTTP, and all sorts of things. But hopefully this shows you how quickly you can build an application. And if you want to learn more, please check out the Tour of Heroes up on the Angular I/O docs. Thank you.
Thanks, John. Hey, could I have the other laptop brought back up, please? Okay. All right. Hey, I'm Brad Green. I'm an engineering director at Google, and I manage the Angular team. I want to talk a little bit about performance, because this has been most of our focus in terms of architectural differences from Angular 1 to Angular 2, is focusing how could we make this run fast. In Angular 1, we'd actually run out of big ideas, things we could push the architecture into to make it fast. And so in Angular 2, we had a fresh start. We wanted to do it really well and really right for you folks. Now, there's not just one aspect that we could say, we got it, we got performance done. There's actually many different places that we had to look to make sure that you could write fast applications using Angular. A couple of the different places. Number one, we wanted to make sure that you could write very small apps. This is critical for startup time in your application, both download across the wire and parsing time on the device, on the desktop, but in particular in the mobile web. We wanted to make sure it's small. And we also wanted to give you control so that you can only load the part of the application that's required to render the view that the user needs to see right when they want to see it. And at the core of Angular, we wanted to make sure that this ran as fast as possible. We wanted to make sure that things execute faster. We just do less work. We have very low memory overhead, particularly for low-power devices, mobile devices, and a lot more. Let's dig in. Let's see how far we got. In the Angular 1 timeframe, we had what I would call interpreted templates, where we actually download your HTML and CSS and JavaScript into the browser, and then we run it through a template compiler that creates a bunch of data structures that allow us to interpret this as your application runs. We do some change detection to figure out what data that you provide should be merged with your templates, and then we render it out to the user. And we do this in conjunction with some other runtime bits, which were great, and it was very dynamic and a very nice developer experience, we think. But there's some overhead here, as you can probably understand, where we're interpreting stuff. It can't be as fast. There's always some overhead in us figuring out what to do at any given point. And so for an Angular 2, we actually took a different approach, where the template compiler actually just runs through a pass one time. And instead of being in an interpreted mode, we generate code. We actually generate code inside the browser. Well, actually, that's how we started. And we eval it to build your application. And so we have this mode that we call just-in-time, or the JIT mode of our compiler, that does pretty much what Angular 1 did, where we download all of your HTML, CSS, JavaScript, and we run it through the JIT compiler, generate the code, and run it. And it has a particularly nice property in that we can build very highly optimized JavaScript code. In particular, we make sure that JavaScript VMs, no matter what browser they're in, they all use the same strategies pretty much, that they can optimize as much as possible by making what are called monomorphic data structures. It means it's the same shape every time the VM comes across something that it needs to execute for you. This gave us a lot of performance benefits. In particular, in change detection, it's over 10 times faster than we were able to do in Angular 1. So this is a pretty good result. Across the board, it's faster. And we actually built a bunch of benchmarks for ourselves to figure out how much faster, in general, would applications perform if I wrote one in Angular 1 and I moved it to Angular 2. And there's one I'm going to focus on right now called Deep Tree. And this is one we built to simulate users going from view to view. We create a bunch of elements, and we destroy them, and we recreate them as if the user had gone from one view to another one. And the first thing we did was we built this using handwritten JavaScript, using all of the performance techniques we knew of to make it fast. We wanted to know how fast could browsers render this type of scenario? How fast could it go if there were no framework involved at all? We then wrote that same scenario in Angular 1, and we found, well, it's about 6 times slower than handwritten. We're not too sad about that, because that was fast enough for hundreds of apps at Google and hundreds of thousands of apps outside of Google. But we wanted to do much, much better. And so in Angular 2, using this optimized JavaScript technique, we're almost 5 times faster than we were able to be in Angular 1, which is great. But we didn't just want to be fast in the execution time. And so we have another mode for our compiler where we don't do it in the browser at all. We actually allow you to do it as part of a build step, where you build your JavaScript bundle. We take your templates in HTML, and we compile them. All that parsing and compilation happens on your desktop machine before you ship it out to the users. And then the only thing that gets shipped down to the users is that generated code. There's no eval step that has to happen, and it runs very, very fast. So in addition to being highly optimized for JavaScript virtual machines, it also has the benefit that we no longer have to do parsing and compilation in the browser. So we skip that entirely. And it's much smaller because we don't have to load that code that would do the compilation and the parsing and whatnot. So we can be very, very small and very, very fast. And again, we did this through our benchmarks to find out how well we did. So if we compare the JIT mode versus the ahead-of-time compile mode, for this deep tree benchmark, we can see it's about a 3x increase, which is nice. And then the size, you can kind of think of this as kind of a minimum application size you can get to, where we had about 144K in the JIT mode, about down to 49K with ahead-of-time compilation. We're really happy about this because in Angular 1, just the framework alone was about 53K. So we're already smaller than we were able to be in Angular 1. We can do better, and we'll see how we're getting there as we go forward. So you might ask, okay, nice benchmarks, Brad, but is there some kind of real-world application we could look at that has some hints? How will this work out for me? And there is one. There's actually several. But one of those that did some really good analysis with us is one called Lucidchart. And it's this nice charting application where they originally built the application using handwritten JavaScript the way we did for our benchmark. And they've ported it, and moved it to Angular 2. And they're now doing A/B experiments where if you're a user, you come in, some days you might get the one in handwritten JavaScript, and some days you might get in Angular 2 because they want to find, if we got all the bugs out, and does it perform as well as we did with our handwritten JavaScript version. And what we find, if we look at the Chrome performance flame chart, we can see, here's what it looked like in JIT mode, where all the way here on the left side, we see Angular 2 start to run its bootstrap. And then in the middle, there's a whole bunch of template parsing and compiling. Angular kind of wakes up again to do its dirty checking and rendering over there on the right, and then finally the loading screen disappears. When they moved to the ahead-of-time compile, this all shrunk down by quite a lot, where you can see Angular 2 bootstraps, and just milliseconds later, we get the first tick, and just a couple hundred milliseconds later, the loading screen disappears. It's much, much faster. In terms of real-world experience, if I'm a user, what would I experience? They've actually been graphing this. And we can see the blue line here is the Angular 2 version. Red is the handwritten. And originally, Angular 2 was a bit slower. But when they turned on the ahead-of-time compiler, we can see that they actually started beating the handwritten version of their application. If you go down a little bit further to the right, they also started to turn on what's called advanced compilation with the Clojure compiler. Now, Clojure compiler is a JavaScript compiler and optimizer from Google that does a couple different things. It optimizes your code, but it also does this thing called tree shaking, where it will delete, it'll eliminate unused code, dead code that your application could never use. So things get faster there as well. Using these techniques, they actually also built a minimum application to see how small could this be, and it's now down to about 27K using these techniques. And you can find out more about this on the Lucidchart developer blog, and you can actually download this repo to see that minimum application size. Now, this is what you get out of the box. There's a couple different things that we wanted to allow you to provide optimizations on top of what we can do. And one of these is, as I mentioned before, lazy loading, where through the router, we actually allow you to turn it on so that you can compartmentalize your application code and only load the code that's needed to render one of your views. And so if one of the sets of components is maybe the first view of your application, that's the only code that's required, that's the only code we should load. We've also recently introduced a way for you to provide strategies to tell it how to optimistically load the other code. So if I'm on this first view of the application, and if you know, well, look, most users then just go to view B, while they're consuming view A or doing whatever they want with it, you can have the router automatically start downloading view B's code, and so it's automatically there, and the user can have a very, very fast experience when they switch from one view to the other. The other thing that we allow you to do is change the way that we do change detection, where by default, we do what we did in Angular 1, which is we just check everything all the time. But as I said, it's about 10 times faster. So for most applications, this is going to be just fine. You're going to be happy out of the box. But if you've got some very expensive calculations you need to do to update your data, or if you've got a whole bunch of data that you want to update, you might want to do something different. One of these different things would be to say, look, hey, Angular, don't check anything. I will tell you when to update stuff. If you want to do it on a periodic interval, if you can know when your data updates, maybe you're using Immutable.js or Rx as a way to figure out when things update, you can turn on this thing called onPush, where you can say that some of my components in my application, or all of them, should only be updated when I tell you. The last thing that we allow you to do is actually completely detach from dirty checking altogether, from change detection, and say, only render this one time. The first time you render it, maybe the user name, that is something that gets populated once, and it's very unlikely that's going to change. And so we'll just say, hey, Angular, just render that one time, and it should be free for me from then on. I never want you to take any time rendering that from then on. So these are the things that we give you today. There's a lot of really good things that you can make high-performance applications. There are some things that we're still developing I wanted to share with you before I go. One of them is support for web workers. Now, one of the problems with JavaScript and just web browsers in general is that they're single-threaded, meaning that if your application is doing some heavy processing, complex calculations, loading data, whatever, your users may see your application slow down or stop for a little bit. And so using web workers, you can actually move some of that off the UI thread and have a silky smooth, completely fast experience for the users. The problem is using web workers is kind of difficult. We've actually added some really nice abstractions on top of this, where you can easily move most of your application code into a web worker out of the UI thread and take advantage of that. We've been demoing this for a while, and we'll be adding more features and making it easier to use. We've also been building support for service workers. Now, service workers allow you to do work in the background when your application is not active. The tab's not active, it's not open, it's not something the user is currently consuming. One of the things we've demonstrated is that you can have, similar to the offline server-side rendering that Jules talked about earlier, we can actually do that within the browser so that when the user comes back to your application a second time, there's an already rendered version of your application already there waiting for them. So that second load experience can be instantaneous. After we had shipped Angular 2, and as we were reviewing how the compiler works, we've identified a bunch of places where we can make it even faster, go even faster than that 1.5 times what our handwritten version was. We actually think it might be fast enough that we can go faster than that baseline, go faster than we can do in handwritten code, because as compilers do, we can see the entirety of an application, and we can make optimizations that would just be too hard for individuals to make. And we've got some high hopes we can go very, very fast there. And the last thing I'll leave you with is I've made a challenge for the team to continue to drop the size down so that we can make very, very small applications. And I've said, well, look, if you can get a Hello World to about 10K, I will bake you a cake. And I'm pretty good, so I think they're pretty jazzed about this. We'll see if that's the incentive that's going to work out, but it's pretty good. So these are in various states. Web workers and service workers are in experimental state. You can use them today. You can try them out. And the faster than baseline and 10K Hello World goals are something we're still working on. We'll probably be rolling that out incrementally as we make improvements, and we'll get it out to you as soon as we can. So up next, I want to talk just a little bit about our documentation, because we know that we could build the best framework in the world, and it would be completely useless if you didn't have really good instruction on how to use it, how to build apps successfully. And so we've focused a lot on building a really nice, rich set of documentation. We've built a great team around it. The lead for this team is Ward Bell, and he's an Angular developer expert. I'd like to invite him on stage to take us for a tour of the docs. Here he comes. Ward Bell.
Okay. Here we go. Let's see if I can get out of presenter mode. Hi, I'm Ward. I am I guess I'd call it the editor of the Angular docs. And to be an editor means that there's a lot of people who are behind it. A lot of great developers like you. They're developers first, and then they write. They've got the passion, and then they write. And so when you go to the doc site, you're seeing the work of people just like you who are trying to do stuff. And they want to tell you about it. And I have no internet connectivity. So this is going to be a very virtual walk. We've got a quick start. We've got a guide that teaches you stuff. We've got tutorials. We have more advanced things. We have cookbooks with recipes for things that you want to do. And inside are code snippets, and every one of those code snippets is real. It's real because it's driven by real code, tested code. So when you click it, you copy it, and you paste it, you know that's the real deal. It's not something that's 6 weeks or 6 months old. And so just to prove to you that we are in great shape here on the net, unbelievable. It actually worked. Well, there you go. So here are some cookbooks. And here's the, I knew that would happen. Okay, so it's all right because we have it over here. When you drill down into the cookbook that's related to, hey, this never happens, right? You drill down into the cookbook, there's Visual Studio. Now, I know John showed you VS Code, and VS Code is great. I do a lot in VS Code, but a lot of us are Visual Studio people, and we like to use Visual Studio. Does Angular 2 work with Visual Studio? Well, follow these instructions, and you will end up with a Getting Started app. And let's see if Control F5, I'm going to I'll give you a tour. This is everything. This is actually an ASP.NET application, all right, empty, with Angular in it, populated in it, and Angular code in it. I know there's a lot of JS things here, but it really boils down to, say, having an app component and an app module, just like you saw. And I have, I can F12 to get places if I was in the module. So it's all there, and I can Control F5, and I get that. Okay, so there you go. You're up and running. You did this by cloning the quick start. Now, this will get you going, but what if you wanted to take a look at, say, some of those samples that I said that were driving the rest of the code? So let's go back. This is going to be ultra hacky, but we love hacky. We're going to go back here into Solution Explorer, take this guy. We're going to delete him. Don't worry, this isn't how it's always going to be. We can go over here, and let's see. That's the wrong one. Let's see. We got that guy. Close that. All right, so we were in the quick start, but we say, hey, you know what? I love that Tour of Heroes sample, so I'm going to drill into the TypeScript version. I'm going to grab that folder, come back over to Visual Studio, paste it. All right, now it's not quite ready. I'm going to do this old trick here where you drop out to show all files, exclude from project, include from project, and presto, changeo. You have Tour of Heroes. Ta-da! Oh, but does it work? Does it work? Does it build? We Control F5, it builds, it started. Isn't that just the way life is? All right. You got to believe me. But, hey, and what's not to believe? But there's better news than that, because that's not the way you really wanted to do it. I promise you it does work, just didn't work for me. But here's the deal. Microsoft and Google are working together to give you the experience you really want. What's that experience you really want? You want templates. You want file new, right? And you can already get a preview of that with .NET Core. If you go to that cookbook, up at the top, there's a link to show you an example of how you can see it for .NET Core, but it's better than that because the Google team is meeting up with the Visual Studio team, and they're putting together a whole series of templates for you that do all the kinds of things that you would expect to see in Visual Studio, building real Visual Studio applications. Thank you, and go out there and write some Angular in Visual Studio.
Thank you, Ward. It's quite a superhero outfit you have there. I'm assuming you got that in my superhero store. Let me hit got it with a Windows machine that I don't remember how to use. Okay, so before we leave you today, there's just a few more things I want to talk about. Angular is an open source framework from Google, and as an open source framework, community is hugely important to us. It's one of the ways that we measure our success. GitHub recently released a State of the Octaverse report, which is basically a report that shows some metrics around big open source projects that are located on GitHub. And we're pleasantly surprised that Angular has over 12,000 contributors. And these are contributors that are not just JavaScript developers, they're enterprise developers and big companies. And they've given us not only code contributions, but they've also given us valuable feedback and use cases so we could make Angular even better for you. But one of the ways that we have traditionally estimated our current community size is with a number of active 30-day users to the doc site that Ward has built for us. So currently, Angular 1 is running about 1.2 million developers, and over 600,000 developers are learning and adopting Angular 2. One question I always get asked, in fact, I got asked this at the speaker dinner like 4 times last night, is why do you use this number? This number is not really a valid number of who's using Angular or how many apps there are. Well, it's really hard for us to actually have any telemetry about who is using Angular. We don't have markers in Angular 2. We can't necessarily tell that a website was built in Angular. More importantly, for every big business I go talk to as a developer advocate, we find out that for every website they've built in Angular, they have 10, 20, 30 internal line of business apps that are also built in Angular. We have no knowledge of those. We recently were at a company in Southern California, and they told us we don't have any websites built in Angular, but we do have 98 internal apps that are built in Angular. We would have had no idea. So we don't really know. We use these as a good marker of whether people are coming and learning and adopting our framework. Together with these guys, our community and our core contributors, we have a growing ecosystem of partners who provide everything from educational curriculums to tools and libraries. We have consultants, and we have our amazing Google developer experts that you can always count on for really great content. And them, together with the people who are actually using Angular 2, are making Angular better for you. Angular was built for Google to solve some Google-scale internal line of business problems. And then we open sourced that, and we found incredible adoption outside as well as inside Google. Currently, Google Fiber, Google AdWords, Google DoubleClick, and our internal CRM application called Green Tea are all already on Angular 2, and there's many more that we just don't name here today. We also have a number of businesses we're aware of currently in production with Angular 2 who have been following us through our beta process. NPR One, Capital One, Lucid Charta, as Brad mentioned, and Fidelity have all joined us on stage at various conferences to talk about their Angular 2 experience, and you can find those videos on YouTube. I came to the Angular team as a .NET developer. I had never faced JavaScript before. I was blown away by what this framework can do to make building applications easier, by the amazing open source community that's helped us build it, and by my ability to solve developer and business problems with this framework. So I'm really looking forward to seeing what you guys build. And if there's anything we can do to make your experience better, please don't hesitate to reach out. Thanks for having us. It's been pretty awesome.